This video is for lesson 41-1, Understanding Conditional Probability. Learning goals are to understand what conditional probability means and to find conditional probabilities from data that's in a table or in a Venn diagram. Let's consider this example in number 1. There are 90 cranes, a crane is a type of bird, that belong to the Cocoa Wildlife Conservation Trust. The cranes have been categorized by gender and type as shown in the two-way frequency table. The first thing we're asked to do is complete the table. It's always easier to find probabilities when you're working with a completed table or Venn diagram. So the total number of gray-crowned cranes can be found by adding the 16 and 13. That's 29. The total number of white-naped cranes can be found by adding 17 and 14. That makes 31. The total number of Stanley cranes is 11 plus 19, which is 30. We can also find totals in the columns. For example, the total number of male cranes can be found by adding up this column. This makes 44. And the total number of female cranes is 46. We were told the grand total is 90, and that can be confirmed by adding across the row or adding down the column. If either of those do not make 90, we know we made a mistake in one of our totals. Now that our table is complete, it'll make finding probabilities a lot easier. Question B, if a female crane is selected, what is the probability that it is a Stanley crane? We know that probability is a fraction and that the denominator is the total that we're choosing from. We're told that we're choosing from the female cranes, so our total is 46. It's not 90, which would be the total of all of the cranes. What is the chance it's a Stanley crane? There are 19 Stanley cranes listed in the female column. And our answer is 19 out of 46. Now question C. Calculate the probability that a crane is a Stanley crane given that it is female. This is really just another way of asking what was asked in B. If we know that the crane is female to begin with, then our denominator is 46. It's not the larger number 90. And the chance that it's a Stanley crane was 19 out of the 46. The example that we just did shows the concept of conditional probability. A conditional probability is the chance that an event occurs given that another event has already occurred. Often, this increases the probability because if you know that one thing has already happened, then your denominator or total that you're choosing out of is a smaller number. In probability notation, we show conditional probabilities using vertical lines. The probability that a crane is a Stanley, given that it is female, could be written like this, capital P for probability, and then in the parentheses we describe what we're interested in. A Stanley, and then see the vertical line? That means given that, we already know it's female. We could further shorten this by using letters of the alphabet, S for Stanley, F for female, and show it like this. So if you ever see these symbols and you know you're working with probability, this means the probability of S given that F has already happened. Go ahead to number 2, and I'm going to pause the video for you to try these questions. What you're asked to do is write the probabilities using the probability notation. Remember, if you're doing a conditional probability, to use that vertical line in between your symbols. I'll help you with question A, and then I'm going to have you do question B and C on your own. The probability that a crane is male, given that it's gray-crowned. We might show it like this. Male, given that it's gray. I'm going to use the letter G to be gray. Please try B and C on your own. Okay, here are the answers. Question B, we want the probability that it's gray, given that it's male. This time it would look like this. Lowercase g means gray, given that is a vertical line, and then maybe M for male, the reverse of the one before. Now question C, we want to do the probability that a randomly selected white-naped crane is female. This would be the probability that the crane is female given that we know that it's white-naped. I'm going to use the letter W to mean white-naped. Now go to the check your understanding. Question 3. The Cocoa Trust Wildlife Preserve also has flamingos, which are categorized as shown in the table. There are male and female, and the types are Chilean and greater. In question A, you're asked to complete the table. I'll pause the video for you to do that. The answer is 29 here, 31 here, 33 here, 27 here, and a total of 60. Now we can do question B, which asks for probabilities. Suppose that a flamingo is selected at random, and use the letter M for male, F for female, and so on. Calculate the following probabilities to the nearest thousandth. That means get a fraction, but then use your calculator to give the decimal to 3 places. I'll start you by doing question I, the probability that the flamingo is male. In the chart, there are 33 male flamingos out of a total of 60. Then I'd use a calculator and go 33 divided by 60. This probability is 0.55, or 55%. Please work on 2 and 3, and I'll pause the video for you to do that. Here are the answers. For number 2, we want the probability that the bird is male, given that we already know it's Chilean. So in the Chilean row, there are 16 male birds, and if we already know the bird is Chilean, there were 29 of those. 16 out of 29. Coincidentally, this is also 0.55. Now question 3. What is the probability the flamingo is Chilean given that it's male? So if we know it's male, we're interested in this column of the chart. There are 16 Chilean males out of 33. 16 divided by 33 is 0.48. Now question C. If a female flamingo is selected at random to the nearest thousandth, what is the probability that it is a greater flamingo? And use probability notation to write the answer. Let's start with the notation. The probability that the bird is a greater flamingo given that we already know it's female. I'll pause the video for you to find that probability. Here's the answer. We already know it's female, so we want to restrict ourselves to this column. The denominator is 27. What's the chance it's a greater flamingo? That's the 14. So 14 out of 27. To 3 decimal places, this is 0.518. Now go to number 4. Let's try another one. As part of their math course, Kate and Rob are required to do a statistical study. They selected a random sample of 80 students from the school, and they asked them what grade they were in and whether or not they had $5 or more with them. The results are shown in the table. So the first thing you're asked to do is to complete that table. I'll pause the video for you. Here are the answers in the last row. 13 plus 8 is 21 ninth graders. There are 19 10th graders, 26 11th graders, and 14 12th graders. We can add that up to see if we really get 80 students like we're supposed to. It does make 80. Now question B, let's do some probability questions. What is the probability that a student has $5 or more given that they're a ninth grader? If we know the student's a ninth grader, then our denominator is 21. It's not 80. How many of those ninth graders have $5 or more? That's 8. So the answer is 8 out of 21. We're asked to give the answer to the nearest hundredth, so 8 divided by 21 is 0.38. I'm going to pause the video for you to try 2 and 3. Here's the answer to number 2. What is the probability the student has $5 or more given that they're a 10th grader? So the denominator is 19. And of those 19 10th graders, 9 of them have $5 or more. 9 divided by 19 is 0.47. Number 3, if we know they're 11th grader, then our denominator is 26, not the 80. And of those 26 11th graders, 17 of them have $5 or more. The decimal is 0.65. Now go to number 7. Let's try the same problem, but with a Venn diagram instead of a frequency table. Some of the truss animals are tortoises and some are not. Some of them are of a known gender and some are not. Let the tortoises be the T and the animals with a known gender be the K. The number of animals falling into the categories are shown. Notice that this Venn diagram is completely filled in because the overlapped region is filled in, as well as the other numbers in the circles, as well as the number in the corner. To help you do probabilities, it's a good idea to know what the total is. 4 plus 20 plus 37 plus 30. That's 91. Normal probability questions would use 91 as the denominator. Conditional probability questions might use a smaller number as the denominator. Now question A, how many animals are there in the location? That was the 91. How many of them are tortoises? Well, how many are in the circle for the capital T? That's 24. How many of the animals are of known gender? Well, how many are in the circle for the K? That's 57. How many of the animals of known gender are tortoises? So in the known gender circle, to also be a tortoise is the 20. Those were all counts of animals. Now go to question E and let's do some probabilities. Use probability notation to write the answer. I'll start you off with number 1. Suppose an animal of known gender is selected. What is the probability that it is a tortoise? So in symbols it would look like this. What's the chance it's a tortoise given that we know the gender? Our denominator is not 91 because we do know the gender. Going back, that was what we found in question C, that there were 57 of known gender. Now of those 57, how many are tortoises? Going backwards, that was the number 20. Our answer is 20 out of 57, which we can change into a decimal. It is 0.350. I'm going to pause the video for you to try question 2. Okay, here's the answer. We want to do the probability that it's a known gender given that it's a tortoise. So first, for the denominator, how many tortoises are there? That was question B. There were 24 tortoises. Now, of those 24 tortoises, how many of them are of known gender? That was the 20. And then 20 divided by 24 is 0.833. Question 3 asks, are those two conditional probabilities equal to each other? And no, they're not. Now work on question 4. I'll pause the video for you. And here's the answer. We want to find the probability that the gender is not known given that it is a tortoise. So for our denominator, there were 24 tortoises. So of those 24 tortoises, for how many was the gender not known? Let's go back to the picture. Here are the 24 tortoises in the T circle, and that 4 is not in the known circle. The answer is 4 out of 24. That's 0.166. Now go to the check your understanding number 8. Recall that in a previous lesson we discussed Annabelle High School and students taking Spanish, and some don't have Spanish. Some have art, some don't. Let S be the Spanish students, A be the art class. The numbers are shown in the diagram. The first thing I notice is it is a complete diagram. It even has the number in the corner showing the number of students who are neither Spanish or art. If we added all the numbers up, we could get the total. It is 350. Regular probability questions, not the conditional probabilities, would use the denominator of 350. Conditional probabilities will restrict that denominator to a smaller amount. Question A, if a student is selected at random, what's the probability the student has Spanish? So in the Spanish circle, we would add 112 plus 84, which is 196, and divide by the 350 students in the school. I'm going to pause the video for you to try the next ones. Here's the answer. Question B, the probability a student has Spanish given that they're in art. So if we know they're in art, our denominator is not 350, but it is the number that's in the art circle. That's 84 plus 98, which is 182. Now, of the 182 in the art circle, how many of them are in Spanish? That's the 84. Now question C, let's just flip that around. What's the probability of the students in art given they're in Spanish? Well, our denominator is no longer 182, it is the number of students in Spanish. So 112 plus 84, that makes 196. And of those 196 students in Spanish, how many of them are in art? That's the 84. Question D, which of the answers was larger? The larger answer is the one from question B, the 84 out of 182. That is a larger number because its denominator is the smaller denominator. Question E, find the probability of S and A given the complement of S. So let's form this fraction. Let's find our denominator, the complement of S, everything that's not in S. That would be the 98 and the 56. That is 154. Then look here. Of those 154 students, how many of them are in Spanish and in art? None of them. So our answer is 0 out of 154, or just 0. Let's summarize. In this lesson, we discussed conditional probabilities, which are the chance that something happens given that we know something else has already happened. From a math standpoint, that involves using a different number for the denominator than the overall total.